So, ladies and gentlemen, what we've done is we've evolved from what we've been taking where we started with. If you guys remember, when we first started looking at evaluating, actually what I would do is I'd just give you a angle. And I'd say like pi over 4. And I said find the sine, cosine, tangent, and all the reciprocal functions, cosecant, secant, and cotangent, right? And what you guys had to do then was go ahead and use the unit circle. You had to determine where that angle was. Right? And you said that's the point. It was square root of 2 over 2, comma square root of 2 over 2. And then you guys could go ahead and evaluate. And remember, I said when you have an angle that crosses and you have a point on the unit circle, right? You have a point on the unit circle. We know that the cosine is equal to the what coordinate? The x coordinate. The sine is equal to the y coordinate. Tangent is y over x, right? And then you have all the reciprocal functions, which just means you take those points and put it over 1. So evaluating for sine, cosine, and tangent, when you have an angle that produces a point on the unit circle that we are aware of, one of those points that we've written down, then it's very, very simple to evaluate sine, cosine, tangent, right? So then that's what we covered in the first section. Then we went into, well, hey, what about if I just give you a triangle and I say, 3 and 4, right? And I say, all right, evaluate sine, cosine, and tangent. Well, then what you guys had to do here was, all right, well, then you figure out, use Pythagorean theorem, figure out what the hypotenuse is. And then you remember that cosine is opposite over hypotenuse. Sine is adjacent over hypotenuse. No. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. And then you have your reciprocal functions, which was just swapping that around, right? Cosecant was hypotenuse over opposite. Secant was hypotenuse over adjacent. Cotangent, which is adjacent over opposite. Yes?
When you don't specify which one is the opposite adjacent, do you just assign
No.
them?
You have to know exactly which one. This one's different. If I say that's my angle, that's opposite, that's adjacent. If I say that's my angle, that's opposite, that's adjacent. So you're always going to be knowing what angle you're using that as a reference. All right? Because, yeah, you just can't look at this triangle and say that which one's opposite, which one's adjacent. You have to be referring to a specific angle. OK? So now what we're going to do is now I'm going to give you guys a coordinate point. OK? So now, just like anything else, ladies and gentlemen, what I want you to understand, Kelsey, you need to put that down and you need to flip it down there. Thank you. So ladies and gentlemen, here, this is so special because we had a triangle, or I'm sorry, we had an angle that produced a triangle that was on the unit circle. And if you guys remember, the reason why why cosine equaled x and why sine equaled y, does anybody remember that reason? I said it only works when it's on the unit circle, and there was a really specific reason why. Something about the value of the hypotenuse. What is the value of the hypotenuse when you have a triangle that's on the unit circle? 1, right? So guys, cosine doesn't ever change from being the ratio of adjacent over hypotenuse. That never changes. Cosine of your angle is always adjacent over hypotenuse. But if I have a triangle that I can write on the unit circle, what is my hypotenuse always going to be? 1. So that's why we said the cosine of theta was just equal to your adjacent side, which on the unit circle represented our x coordinate. All right? But now, ladies and gentlemen, remember, unit circle has that radius of 1. If I plot this point, 3 comma negative 5, 1, 2, 3, 1, 2, 3, 4, 5, is that point on the unit circle?
Yeah.
No, right? The unit circle, remember, has these coordinate points like this, right? That's the unit circle way over there. So I can't just say, oh, cosine is equal x and sine equals y. No, because my hypotenuse is not equal to that value, right? So again, ladies and gentlemen, what I need to do now is I need to create a triangle. So to do that, you're going to want to create a triangle, right, by drawing a perpendicular line to your x-axis. That's supposed to be over 3. So I'm just going to draw that up there, make that a right angle. And I know that this distance, remember, here's the point, 3 comma negative 5. So this is my x. This is my negative 5. Right? And then can I still find my hypotenuse? Yeah, just use Pythagorean theorem again. So I do 3 squared plus negative 5 squared equals, let's call this c squared. C squared. So that's 9 plus 25 equals c squared. 34 equals c squared. Square root. C equals plus or minus the square root of 34. However, ladies and gentlemen, when we're talking about a hypotenuse, you guys know that x can be positive and negative, right? Y can be positive and y can be negative. Your hypotenuse is always going to be a positive value. All right, the x and y's are positive, negative. The y's are positive, negative. Your hypotenuse is always going to be positive. Always. Okay? So just remember that when you guys have like positive and these negative values, please remember, you might even want to write it down, that the hypotenuse is always going to be represented by a positive number. We don't ever represent the hypotenuse as a negative number. And that's become very, very important when we start talking about some of these trig functions. So it's just going to be the square root of 34. Now, to save myself some time, can you guys now do the sine, cosine, and tangent of that triangle? Would you guys feel comfortable, or do you guys want me to show you again? Yes?
Wait, so where the circle is where the angle is, right? This is where the round part only is? Because wouldn't that be how you find what the...
Yeah, I'm not asking you, though, to find the angle at that point. But I'm asking you just to evaluate sine, cosine, and tangent for that. Yeah.
But don't you need to know like where it is to do the Pythagorean theorem?
Yeah, well, that's what this triangle was. That's why I created the triangle.
No.
No, what's your question? It's okay.
Okay, I get it.
Okay. So the main important thing that I want you guys to write down, okay, when you have a point, this is something I've said over and over and over again, when you have a point that lies on the unit circle, right, we know cosine is x, sine is y, tangent is y, or y over x, right? Cosecant is 1 over y. Secant is 1 over x. Cotangent is x over y, right? We've already talked about all those. But when you have a graph, when you have a point on the unit circle, it's as simple as using the coordinates. But what I want you guys to write down again now is when you have a point that is not on the unit circle. When you have a point that is not on the unit circle, and you guys can easily tell this is not on the unit circle, right? The unit circle only goes to 1, negative 1, up 1, and down 1, right? So this point is definitely not on a circle. You have to create a triangle. You have to create a triangle. And once you create a triangle, then you can do the sine, cosine, tangent, do Pythagorean theorem, and do the rest of it. All right? Make sense? Yes?
Where did you get -5?
Like here? It was just that was the point that I gave you. So in your homework and on a test, I'll give you a point, and I'll say, hey, tell me what sine, cosine, and tangent are for that point. And you say, oh, since it's not on the unit circle, I need to graph it, draw the triangle, find the hypotenuse, and then figure out the sine, cosine, tangent. Okay? And just remember, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, cosecant hypotenuse over opposite, secant hypotenuse over adjacent, cotangent